Riya Kankonkar's channel, and today we will be learning a new topic from lesson number 1, Similarity, that is property of an angle bisector of a triangle. This property consists of a theorem. So let us now learn what is the theorem telling us about the angle bisector of a triangle. Here the theorem tells us the bisector of an angle of a triangle divides the side opposite to the angle in the ratio of the remaining sides. Let us now learn it in the form of given and to prove. The sentence from the start tells us the bisector of an angle of a triangle. That tells us that there is a bisector for one of the angle of the triangle. The second point tells us it divides the side opposite to the angle. That is, the bisector is intersecting one of the sides of the triangle and it divides the side into two different parts. What does it tell us? It tells us that the bisector divides the side opposite to the angle in the ratio of the remaining sides. Now let us learn this in the diagram. Here in the diagram, it shows us there is a triangle named triangle ABC and the bisector of angle C is ray CE, which is intersecting side AB, that is opposite to this angle AB, in two different parts as AE and EB. That was the given part, and the to prove part tells us that AE upon EB, that is the side intersected by the bisector and divided into two parts, equal to the remaining two sides AC upon CB. Next, they tell us to do a construction, that is, we have to draw a line parallel to ray CE which is passing through the point B upwards because it has to be parallel to ray CE, and we have to extend side AC to intersect at point D here. That was the construction. As we just learned, the given part and the to prove part is here and the construction part is given here. Now let's learn the proof. The first thing in the proof is ray CE is parallel to ray BD and AD is transversal. Let us see in the diagram now. The diagram will look as this. So the diagram for the first step goes as this. AD is the transversal and CE and DB are parallel lines. So what do we learn from this? That ACE and CDB are equal because these are corresponding angles. Why are they equal? Because they are corresponding angles. And which are the angles? Angle ACE and angle CDB. That is what is told here. Ray CE is parallel to ray BD and AD is transversal. Therefore, angle ACE is equal to angle CDB because they are corresponding angles. That is step 1. Now let's move on to step 2. Now taking BC as transversal. First we had taken AD as the transversal and now we are taking BC as the transversal. But ray CE and ray BD will be the same as before. That is, they will be parallel. Now let's see the diagram. In the diagram, CE and DB are parallel and BC, that is this line, is the transversal. So let us see how will the diagram look separately. So here, as we see, ray CE and ray DB are parallel lines and BC is the transversal. From this, what do we see? What do we see in this diagram? That angle ECB and angle CBD are equal because they are alternate angles. Which are the angles? Angle ECB and angle CBD are equal. Why? Because they are alternate angles. And in the first step, we learned that angle ACE and CDB are equal because they are corresponding angles. Let us now see the proof. Now here in the proof, they tell us that angle ECB is equal to angle CBD because they are alternate angles, and that is step 2. After that, they tell us, but angle ACE, that is this angle, and angle ECB, that is this angle, are congruent. Angle ACE from step 1 and angle ECB from step 2 are congruent because it is already given to us. As angle ACE and angle ECB are equal angles or congruent angles because the bisector is bisecting the angle C in two different parts. Then they tell us that therefore angle CBD is equal to angle CDB from 1, 2 and 3. As left hand sides of both of these angles are congruent, therefore the right hand sides become equal. Now let's move ahead. In triangle CBD, side CB is congruent to side CD because sides opposite to congruent angles are equal. Let us see in the diagram. What does it tell us? It tells us side CB and side CD are congruent because their angles which are opposite to these sides are also congruent. It is related to the isosceles triangle theorem. And the next step tells us that in triangle ABD, the bigger triangle ABD, here segment EC is parallel to segment BD as per construction. Therefore, using basic proportionality theorem, we get AE upon EB is equal to AC upon CD, and CD is equal to CB. Therefore, we'll substitute CD as CB in the next step. That will be AE upon EB is equal to AC upon CB instead of CD. Let us see in the proof. So here in the proof, it is telling us in the written form that AE upon EB is equal to AC upon CD due to basic proportionality theorem. And the next step, it substituted CD as CB, and that is how we have proved the angle bisector theorem. This was to be proven and we proved the angle bisector theorem. So this was all for the property of angle bisector of a triangle. In the next video, we will start with the practice set 1.2 of lesson number 1, Similarity from Mathematics 2, that is Geometry. See you in the next video. Until then, bye.